Draw this, everyone. Quick. Now I am going to resolve and show you how to resolve the stresses at different orientations. First we will do some hard work, then we will do some smart work. Okay, I'll give you the shortcut also to find these stresses, but you should know how to resolve the stresses first. You know about resolution, resolving the parameters on a different orientation planes. Have you done that before? No one? So this is sigma xx. Draw this. This tau xy. This is your sigma y. Okay. So now, whatever I am going to draw, please remember, so on which plane I am making the angle. Okay. So now I will cut a plane. Let's say I'll cut this into two halves. Cut this body into two halves. So there is a plane passing something like this. As of now, we don't know what kind of stresses will act on that plane. And now I am going to assume that, so this is my maxima plane, you can say, or minima plane, whatever it may be. I'm just assuming it. I don't know as of now. And make some angle with respect to vertical. So this is my theta. Remember, I am making angle with respect to the vertical line, not with the horizontal one. Okay. Now what I will do, I will take only this half. Then I will try to see what kind of stresses will act on that plane. Okay. Just a second. I will draw the elaborated picture of that. It's a triangle. Draw this, everyone. This will be fine. Draw this. Now tell me, this is the plane I cut. So what are the stresses that is going to act on that plane? Come on. Normal stress and there will be shear stress. Agree? Guys?
Yes, sir.
So this is your sigma n and this is your tau. We are going to find what are these stresses. Sigma n and tau. And you are going to have these sigma xx and tau xy as it is. This is the part of the free body diagram. There is shear stress. There is shear stress like this. Come on, draw this. And this is your sigma xx. This is your tau xy. This is your sigma y. Okay. And this is the angle we made with respect to vertical. So in some textbooks, what they will do, they will try to take the angle here. So if you are trying to take the angle here, what is the angle? Is it theta or 90 minus theta? Come on. What is the angle at this location now?
90 minus 3.
90 minus theta. Okay. Now, if I want to find the sigma n and tau, how I should do that? What do you have to do to find the sigma n and tau? We should resolve sigma xx and sigma yy and tau xy in the direction of sigma n and tau. Agree? Yes?
Yes.
Then after that, what you should do? After that, what you should do?
Equilibrium.
Equilibrium. Very good. Keep it up. So now, so before resolving, what I will do, I'll try to consider the plane. I mean the coordinate system. So just a second. This is my x-axis. Make a dotted line. And similarly, make one more line like this, so that you will get that feel of how to resolve the things. This is my y, and write that. This is my x, this is my y. Now you are going to resolve this sigma xx, sigma yy, and tau xy in the positive x direction and in the negative x direction. Similarly, in positive y direction and in negative y direction. Understood? Now the first result. Now the first resolution will come from sigma xx. Observe this. Now I will resolve along the x direction. I mean along this line and perpendicular to this line. Now you have to tell me which angle is theta here. Don't do any mistake. So either this angle is theta or this angle is theta. I'll give you the options. These one, these two. Tell me the angle. Which one is theta or 2 is theta? Don't do theta. Wrong. And obviously, if 1 is not, 2 is the one. If I make this angle theta, any doubts? You want me to explain how this angle is becoming theta? Or you know this? It is simple math. You must have known this already, how to resolve and how to see the angles. You want me to show that, guys?
Okay. Sir, is it opposite angle?
No, not like that. You can't say directly opposite angle. See, if I take this stress, and obviously it is constant along that face of the element, it is constant. If I am moving that stress to that point, now observe this. Now if I draw one more extension of that line, then I have this one here and I have this one somewhere here. Something like this. Now, if this angle is theta, which angle is theta? This angle is theta or this angle is theta? 1 or 2? Come on.
2.
2. So, if this angle is theta, what about this one? What about this one?
Theta.
90 minus theta.
90 minus theta.
What about this one then?
Theta.
Theta. Now you understood?
Yes, sir.
Okay. So, this is how you should do. It is not about always opposite angles. Please remember, don't do that mistake. These are the mistake people will do often. Okay. Now, I am going to name this as A, B. Write this. A, B, and C. I'll tell you why I am doing that. Now, if you want to balance, if you want to do the equilibrium, can you do equilibrium of stresses? Is there anything like that? Guys. Or you have to do force. See, what is equilibrium? When you will say equilibrium of a body, I mentioned this condition already. Summation of all the forces and moments are 0. Agree?
Yes.
Okay. So if summation of all the forces should be 0, so you have stress here. How you will convert that as a force? Now first resolve. So can you tell me this component now? It is sigma xx cos theta or sin theta?
Cos theta.
Cos theta. So this is stress. How you will convert this into force? By multiplying its
Area.
area. Tell me what is area of this one? See, it is 2D. You are unable to see this one. So in that case, what I told you?
B into 1.
B, not B. It is AB. Correct? Guys, are you able to understand this?
So,
So into AB, write this. So now this will become a force. That is only one component. Okay. Similarly, if you observe this one, it is sigma xx sine theta. Again, the area will become AB. So that's why I gave you those alphabets, so that it will be very easy to write the areas. So try to remember the unit depth part. Okay, for a 2D plane. Similarly, if I go with sigma yy, now you have to tell me which angle will be theta. Okay, I won't be giving you any hints now. Now I will resolve this along the direction of y and perpendicular to the direction of y. Now tell me which one is theta, 1 or 2. See why I am taking this much time for this. Sometimes you won't be able to remember the formula, at least. So tell me which angle is theta, 1 or 2. Is my screen is visible?
2.
2. Who is this?
X.
Fine. Very good. Everyone is getting? So this will be theta. Now you write sigma yy cos theta. So what is the area? BC. Okay. Similarly, sigma yy sin theta again into BC. So now you resolve two parts. Similarly, now I will resolve. Anyway, if I resolve there, it will be more clumsy. I'll try to take tau xy on the x plane. So this is tau xy of this one. Are you able to understand? Now if I try to resolve this along the plane and perpendicular to the plane, now which angle will become theta? This will be theta. So this is tau xy and this will become tau xy cos theta into AB, and this will be tau xy sin theta into AB. Can I continue? Are you done with this?
Yes.
Sir.
So similarly, if I resolve tau xy of BC, it will be along this and perpendicular to this. So again, this angle will be theta, and this is my tau xy. Tau xy cos theta into BC, and this will become tau xy sin theta into BC. Write this. So you are done with all the resolution. So now you have everything in x and y direction. And what about sigma n and tau? If you want to balance this as a force, what you have to multiply these two parameters with? Come on. To convert this
AC.
Great. So this also you multiply with AC. So now the complete free body diagram is all about the forces, force balance. Okay. Now I will do that. You are done with this, everyone? Guys, any component you missed, please draw it very carefully. Okay. Because when you are balancing, you have to take each and every component into picture. Then you have to solve that. Okay. Now, the force balance, summation of all the forces in x direction is equal to 0. This is your first equilibrium condition. So, what is the positive force? First we have guys. So this is your coordinate system now. Okay. So whatever the forces in the x direction, you should consider that as a positive force, and whatever the forces is in opposite direction of the x, you should consider that as a negative stress or negative force, you can say. Now go ahead. What is the first one? It should come
Sigma n AC.
Correct.
Sigma
Sigma
n
n AC. So I will write directly that is equal to, because if you see all the stresses is in the opposite direction of that coordinate system, then the next one I'll take this space first. So it will be this one. Okay. That is sigma xx cos theta into A. Write that plus you will get is there anything on y plane which is in x direction? Yeah, this one. So that is going to be sigma yy sin theta into BC plus you check for tau xy. So in this plane, which one? This one will be in the x direction. That is tau xy. Is it cos or sin? Sin, right? Sin theta into AB plus tau xy. That will be cos theta into BC. Everyone understood this step?
Yes, sir.
Okay. So now what I am trying to do, I will eliminate this AB and BC. These parameters I don't want into picture. So for that, if you see from the triangle, what is sin theta, guys? What is sin theta? BC by AC. Can I write that? What is cos theta? AB by AC.
The
Agree?
shear forces will be negative, right? It is in
Which?
the opposite direction.
So that's why
Top.
I'm writing equal to. So if you write on the LHS side, it will be negative.
Okay.
If you write it on the RHS part, it will be positive, right?
Okay.
Correct. So from the triangle, I can write these two. Sin theta is equal to BC by AC and cos theta is equal to AB by AC. Now divide entire equation by AC. Do that. If you do that, you will get on the left hand side sigma n only. That is equal to sigma xx cos theta. What is AB by AC, guys? What is AB by AC? See,
Cos theta.
so I can write this as cos squared theta. Agree? Cos theta into cos theta. Cos squared theta I can write plus sigma yy. Tell me, what is BC by AC?
Sin theta.
Sin theta. So I can write this as sin squared theta plus, if you see, AB by AC is cos theta and BC by AC is sin theta. So tau xy sin theta cos theta, tau xy sin theta cos theta. Can I write 2 times of tau xy sin theta cos theta?
Yes, sir. Yes, sir.
So I can write this as sin 2 theta. I hope you know about these things, trigonometry. Bracket this. It's a very important expression. So many times questions came on this. Okay, now you are able to get what is the normal stress on this plane. Agree? So now I am going to shorten this a bit to get into more modified version of that formula. I'll use little bit of trigonometry. Cos squared theta can be written as 1 plus cos 2 theta by 2. And similarly, sin squared theta can be written as 1 minus cos 2 theta by 2. Write this. Then, if I substitute it in the above formula, the sigma n will become, that means the normal stress, that is equal to sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 into cos 2 theta plus tau xy sine 2 theta brackets. Mark this one as equation number 1 in this chapter. Very important equation. And you can call this one as sigma average stress. Now, can you balance the force in y direction and tell me what is tau? I'll give you some time. Come on. I will give you 3 minutes. Can you do that? Yes? So do the force balance in y direction and tell me what is my shear stress on that plane. See, once you are able to find stresses on different planes, it is very easy. Complete strength of materials will be fun. Okay, nothing to do with strength of materials. If you are able to find the stresses at different orientations. Okay, that is the key part in strength of materials. You take any chapter, you will talk about stress. Don't get stressed by resolving these things. Okay. Make it as a habit of deriving some things which you will understand it better. Okay. Always derivation will give you some confidence about remembering the formula. I will show you in a graph after a break. Okay. So if you don't have this graphing calculator, you please download this name as Desmos. Anyone knows this? Desmos graphing calculator. You download this in break. I'll show you how to use that.
Excuse me, sir.
Hmm.
Sir,
Any doubt?
sir, I got the equation.
Yeah,
not
but
sure.
tell me the equation.
Sigma xx minus sigma yy by 2 sine 2 theta plus tau xy cos 2 theta.
Are you getting sigma xx minus sigma yy or sigma yy minus sigma xx?
Sigma xx minus sigma yy.
Wrong.
Sir, I'm getting sigma yy minus sigma xx.
Who is this?
Sivapriya, sir.
Very good. Correct. Sigma yy minus sigma xx by 2. Continue. Are you getting sine or cos? Who gave that answer? Sigma yy minus sigma xx. Go ahead from there. So if you balance the force in the y direction, I'm not going to do that. It's very easy. The force balance. By this time, you must have some idea on this. I derived this for differential element in theory of elasticity also for that element. How to balance the forces. It's very important to solve shear force and bending moment or slope and deflection, whatever it may be. Trusses or buckling of columns. Force balance and moment balance. You must know how to do that. If you are not getting hands-on experience on this, please practice some numericals on that. You try to take that UC Zindal, you'll get a lot of force balance and moment balance questions. Okay, practice those. Then if you have any doubt, please come back to me. So the shear stress will get like this. Sigma yy minus sigma xx by 2 into, it should be sine, not cos. So these formulas, by the end of today's class, you must remember this. Okay, plus tau xy cos 2t brackets. Okay, this is your second equation in this chapter. See, in some textbooks, they will give you sigma xx minus sigma yy by 2 because they are going to take that shear stress in the downward direction. If you are taking in the downward direction, you will get the opposite formula, what you guys are telling. Are you able to understand this, guys?
Yes, sir.
Don't get confused with the sign conventions. Okay. So I am deriving this using UC Jindal. So please follow that. It's right derivation, and most of the gate questions will come from these two formulas. 1 mark pakka every year will come from this. The free body diagram also will look similar to this. Okay, whatever they are going to give you in gate exam. Please remember